All right, so number 23, particle motion. A particle travels along a horizontal axis. Its position function is given by this here. So I know S of t, we said, typically represents position, so just kind of give yourself that little reminder. Part A says find the average velocity. So this is something we briefly talked about at the end of class or during our review on Wednesday. Velocity, by definition, is the slope of the position function. They want the slope on this graph between these 2 points. This is an Algebra 1 question. This has nothing to do with the derivative, right? So they're saying find the change in y over the change in x. This is Algebra 1. y2 minus y1 all over x2 minus x1. Just happens that our y's are positions. So we're going to do the position at 1 minus the position at 0 all over 1 minus 0. Okay, so I'm going to go plug in a 1 to get 4/3 minus 7 plus 6 minus 2. Then I'm going to go plug in a 0 to get a negative 2. That's a 2 all over 1. So I have a negative 2 and then I have a positive 2, so those are gone. I have a negative 7 plus 6, so I have a negative 1. So I have 4/3 minus 1 all over 1, or 1/3. Okay. Part B says find the speed of the particle at time 1. Remember, speed is the absolute value of velocity, and velocity is the derivative of position. Now we are talking about derivative because they want it at one point in time, not between two. So we are going to take the derivative, and I'm just going to come do that up here, just for space purposes. So the power rule says bring that 3 down in front and multiply. So I have 3 times 4/3, we'll clean that up, subtract 1 from the exponent, minus, bring that 2 down in front and multiply, subtract 1 from the exponent. The derivative of 6t is just 6, and the derivative of the negative 2 is 0. So I'm left with 4t squared minus 14t plus 6. This is my velocity function. So if I want the speed at 1, the first thing I'm going to do is find the velocity at 1. So I'm going to go plug that 1 in. Technically is squared. So I get 4 minus 14 plus 6, or negative 10 plus 6, or negative 4. That's my velocity. Now I want the speed. The speed is just the absolute value. Okay. Part C says at what time, so they're looking for me to solve for t, is the particle at rest. At rest means it's not moving, which means its speed is 0, which also means its velocity is 0. So I'm going to take that velocity function that we found above, and I'm going to set it equal to 0. So I'm going to factor out a 2, and then we'll see if we can keep on factoring. Let's try a 2t and a t. Let's put a 3 and a 1, minus, minus. So I'm going to set each of those pieces equal to 0, so I get t is equal to positive 1/2, and t is equal to 3. And I'm going to keep both of those because it says time is greater than 0, so we'll keep those. If any of them happen to turn out to be negative, that's when we would eliminate one. All right, part D says find the acceleration. Acceleration is the second derivative of the position. So we already have the first derivative. Let's take the derivative of velocity to get the acceleration. So I'm going to take the 2 down, so I have an 8t minus 14, and then the 6 goes away. Well, they want the acceleration when time is 1. So we'll just go plug in our 1 to get a negative 6. Number 24, well, multiple choice here. Which of the following expressions represents the slope of the sine function when x equals 1. Now, we know that slope comes from derivative, but they're not derivatives. This is going back to the old method, and we have a formula for that. The limit as h approaches 0 of f of a plus h minus f of a all over h. So while I said we're done doing derivatives the long way, it doesn't mean we can kind of forget about what the long way was. Our a is x equals 1, so our a is 1, so I have the limit as h approaches 0 of f of 1 plus h minus f of 1 all over h. Well, our function is the sine of x. So if they want f of 1 plus h, it's the sine of 1 plus h. I'm moving all over the place, sorry. So I have the sine of 1 plus h minus f of 1, so minus the sine of 1 all over h. And the only one that says that would be letter D. Okay. All right, let's do this last one here on the non-calculator portion. We have a function shown below, and I'm sorry the graph did not turn out very well. Find the average rate of change of f from 0 to 8. So rate of change means slope, average means between 2 points, and those 2 points are 0 and 8. So here's the point at 0, and here's the point at 8. This is an Algebra 1 question. I want you to find the slope of that segment. So again, we're doing y2 minus y1 all over x2 minus x1. So let's see, this is the point 8 comma, let's call it 24, 25, I don't know. This is the point 0, 40. So we'll do 24 minus 40 all over 8 minus 0. And again, these are approximate values. The graph is not very clear, that 24. So I don't know what I put on my answers, if I did like a 25. Honestly, I don't remember. Good news here, 24 minus 40 is negative 16. Negative 16 divided by 8 is negative 2. So again, this is an approximated value. I should have said estimate because of having to eyeball that y value there.